In this video, we will look at a few examples to practice working with properties of parallel lines and transversals. So in example A, we're asked to find A, which is the length of this little segment. Notice that we have three lines that are marked as being parallel that are intersected by two transversals, which are any lines that just cross another line. Now, because the lines are parallel, it means that the four segments that have been created have been divided up proportionally. So specifically, A over 20 has to be in the same ratio as 9 over 15. So because that is true, we can set up a proportional equation, which we can solve by cross-multiplying. So we're going to multiply 15A equals 180, which means that A equals 12. Now, before we go on to the next problem, just a reminder about how we got this equation to begin with. You want to take two segments that are on the same line, so A and 20, and line them up with the two segments on the other transversal. Just make sure you do it in the same order each time. So since A and 9 were in the same place, they're on the top part, you want them to match up in your equation. You wouldn't want to do A over 20 equals 15 over 9 because you would end up with a different answer that would be incorrect. All right, example B is next, and in this case, we're going to find B. So this is the same thing. We have three lines that are marked as being parallel. They're intersected by two transversals. So the four segments here that are created are going to be all proportional to each other. So specifically, B over 12 will be the same ratio as 24 over 9.6. So again, we can solve this by cross-multiplying, and you get 9.6b equals 288, and when you divide by 9.6, you get that b equals 30. It's always good to do a reality check to make sure that your answer makes sense in the context of the problem. So if we look more closely on this bottom part here, the 9.6 is smaller than the 24. So it should be the case up on top that 12 is smaller than 30. And it is, so that's good. Also between the two sides, 9.6 is smaller than 12. And again, it works here, 24 is smaller than 30. So it does make sense. It seems to be approximately the right idea of a number, so you can be more confident in your answer after doing that reality check. All right, and let's look at example C. Find the value of x that makes the lines parallel. So in order for the lines to be parallel, it means that these segments must be in the same ratio. So specifically, 5 over 8 must be in the same ratio as 3.75 over 2x minus 4. And if they are, then the lines will have to be parallel. So we can solve this for x, and then we'll have our answer. So again, we're just cross-multiplying like we've been doing in all of these examples. 8 times 3.75 is 30, and then we're going to distribute in a second the 5 times 2x minus 4. So we get 10x minus 20. Add 20 to both sides, and we have 50 equals 10x, which means that x must equal 5. So if x equals 5, then these segments are in the same ratio, which means that the lines must be parallel to each other.